Welcome back. In this video, we are going to see what are the properties of a binary tree, and we are going to see what are the different ways by which we can represent a binary tree. So let us start with the first one. So we are going to see what are the properties of a binary tree. So let us see the maximum number of nodes on a given level and depth. So if you look at the given tree, so please take the root has got level 1. So we're going to take this as got level 1, and this is 2, and this is 3. So what we do is we are going to find the number of nodes on level I. Let us take I is equal to 2. So we are going to take I is equal to 2. So it says that at level I, it should have maximum of 2 power I minus 1. If I take I is equal to 2, which is going to be 2 power 2 minus 1, so which is going to be 2. That means at level 2, it should have how many nodes? 2 nodes. Next, the maximum number of nodes in a binary tree of depth k. So please don't get confused with the levels and depth. So depth is going to give you the complete number of nodes at the given depth. So the starting from the root till the given depth. So let us take again. We starts with 1. Then the next one is going to be 2. This is 2, and this is 3. So it says at depth k. So let us take k is equal to 2. So till this depth, so what are the number of nodes? The number of nodes as you could see on the screen, which is 3. Now let us implement this formula. So when you do this, you'll be getting 2k. K is going to be 2 again. 2 power 2 minus 1. So which is 3. So if you take the depth k, at this depth, right from root, we have got 3 nodes. So this is what the second property says. So we have root which is named as A, B, and C. So let me conclude. So the maximum number of node on level I of a binary tree is given by 2 power I minus 1. Where in case of depth, which is going to be 2 power k minus 1, which is going to give you the nodes which is starting from the root till the given depth, which gives the all number of nodes, the total number of nodes. So please remember, you have to consider the depth for the root is going to be 1 in case of depth, and when you take level, let me repeat, for the root you should consider as 1. So these 2 points you have to remember. So you have to take root as got level 1, and the root has got depth as 1. Next, let us see what are different ways by which we can represent a binary tree. So normally we use two kind of representation. One is the array, second one is linked representation. So both the things we have studied in the previous classes and previous years. You know what is array representation, and you know what is linked representation. So let us see this one by one. So a tree can be represented using an array, so which will be represented in the form of a sequential way, which will be represented a linear way. And what happened is nodes will be numbered from 1 to n, and we are going to store this in a one dimensional array. So let us see the diagram for this. So where you can find two trees, one is skewed binary tree, other one is complete binary tree, and both the trees we are going to represent using an array. And look at this. So its index starts with 0, but we are not taking the first index as I told before. So we are going to start making use of the index number 1. So A has got index 1. See, A has got index 1. So this is for the first diagram. A is at index 1 and B has got index 2, and see, there is no right child for A, so this part we are going to leave empty. So right from root we are going to number it. So A is 1, B is 2, and the right child is supposed to be 3. We are going to leave it. Then C is going to be 4. It has no right child, which is 5. Then for this again 2, this is missing, so we are not making use of it. So if you proceed like this, 8 is going to be the number for D. You could see here, and E is going to be 16. So we are going to start numbering every node which is starting from root node till the last node. So this is for the first tree, and the first tree is a skewed binary tree. Look at the second one. Again, its numbers start from 1, then this takes 2, this is 3, this is 4, 5, 6, 7, 8, and 9. Look at its the way the we represented this, and there is no empty space, there is no blank space, because your tree is a complete binary. So these are the ways by which we can represent a skewed binary tree as well as a complete binary tree in the form of an array. See, the difference is, the main difference between a skewed binary tree and a complete binary tree is no space is wasted. You can see on the diagram. Look at the first diagram and the second one. So in the first diagram, there are many spaces which got wasted. But if you look at the second, no space got wasted. So this is the major difference. So almost half of the space got wasted in the case of skewed binary tree. Let us see the next way of representing this, which is a linked representation. So as I told, a link, we are going to represent the given tree in the form of a linked list. So when I say list, when I say link, every link has got 3 information. And what is advantage? When I represent a tree in the form of a list, a linked list, insertion and deletion from any node anywhere can be taken. So the whatever the drawback in the array representation can be overcome using linked representation. What was the drawback? One was so much space got wasted in case of array representation. Second was we cannot insert and delete a node from the middle of a tree if it is represented in the array. We can represent, but many nodes has to be move to make the changes. So much changes you have to make. So this can be overcome by taking a linked list, or by linked representation we can overcome. So let us see how we can do it. So as I told, every node has got 3 things. One is left child, then right child, and the middle part we call it as the data or the actual information. So let us see what is the piece of code is going to look like. So normally we do take a structure for this. So if you want to represent a tree in the form of a node, obviously you need to take 3 members for the structure, which is going to be data. Data is for the actual information, and the next is going to be the left child and the right child. So this is what